Okay, welcome. Today we start the second day of second day of section 3.7, and today we're going to deal with absolute value inequalities. So yesterday you should have saw absolute value equations. Today we're going to be looking at absolute value inequalities. So a lot of similarities, a couple things that we got to do a little bit differently. So first of all, I just want you to try and solve these four absolute value expressions. See if you can evaluate and see what you get. So hopefully for the first one, absolute value of 7, we know that 7 is 7 away from 0, so we just get a 7. Number 2, it says the absolute value of a negative 9. How far is the negative 9 away from 0? That would be a 9. Number 3, if I have the negative, the absolute value of 4, hopefully we can realize that that's going to give us a negative 4. And the last one, number 4, opposite or negative, the absolute value of a negative 8, that is going to give us a negative 8. Okay, so today we're going to be looking at absolute value inequalities. So we have to think a little bit on these. So I like to do some graphs for these to get us started. So I think the graph is easier to come about than what the actual solutions would be written as. So first of all, absolute value of x is less than 6. So what is this asking for? It's asking us what number is less than 6 away from 0. So if we're thinking about on a number line, I know I got 0 in the middle. So what numbers are less than 6 away from 0? Well, if I'm thinking of it that way, I know I've got some boundaries. I know I've got a negative 6 over here. I know I got a positive 6 over here. So what numbers are less than 6 away from 0? I can picture that that's going to be these numbers in between here. Those are all less than 6 away from 0. But when we're graphing, if we don't want to include the numbers at our endpoints, we use open circles. So our graph would look like that. 2 open circles at a negative 6 and a positive 6 because we can include them. And then it would be all the numbers in between there. Those would be all the numbers that are less than 6 away from 0. Or they would satisfy the absolute value of x is less than 6. So how do I write that as an inequality? Well, if you remember, there's two ways. You could write it as a sandwich, which would say this: negative 6 is less than x is less than 6. Or you could have wrote it as a compound inequality with an and in it. You could have said x is greater than a negative 6 and x is less than a 6. To me, it's just easier to write the sandwich version, but either one is correct. Okay, if I looked at number 2, very similar problem. However, now it says the absolute value of x is less than or equal to 8 away or 8. So now we're thinking what numbers are less than or equal to 8 away from 8. So now I'm thinking, okay, here's my 0. Less than or equal to 8 away from 0, I should have said. So I've got my 0 is in the middle, and I'm thinking, okay, my boundaries are a negative 8 on this side, a positive 8 on this side, and what would I have? I'd have 2 closed circles, because now it could be an 8 or a negative 8. So I got 2 closed circles, and now it would be all these things in here. So what's that going to look like as an inequality? Well, it would say negative 8 is less than or equal to x is less than or equal to a positive 8. Or if I wrote it as a compound inequality with an and, it would say x is greater than or equal to negative 8 and x is less than or equal to a negative 8. The next one, absolute value of x is greater than 2. So now we're thinking on a number line, what numbers are greater than 2 away from 0? So again, I'm going to have 2 and a negative 2, but now we're greater than 2 away from 0. So in my mind, I'm thinking, okay, I know I'm going to start here, I'm going to go off to the right, or I'm going to start here, I'm going to go off to the left. So now if I'm thinking, what is this kind of compound inequality? This is those that were the or statements. So I know that x has to be less than this negative 2, or x has to be greater than this positive 2. So does it satisfy? Do some of these satisfy? The absolute value of x is greater than 2? Sure, you could pick a 3 out here. 3 is greater than, the absolute value of 3 is greater than 2. Or if I put a negative 2 in here, the absolute value of a negative 3 is 3, so 3 is greater than 2. Okay, so it does work. The last one, it says the absolute value of x is greater than or equal to 4. So now again, this is asking us what number is greater than or equal to 4 away from 0. So greater than or equal to 4 away from 0. So now I could include the negative 4, and anything to the left of it would be more than 4 away from 0. Or we could have the positive 4 and anything to the right of that. So what does that look like when I'm talking about a compound inequality? It would say that x has to be less than or equal to a negative 4, or x has to be greater than or equal to a positive 4. So if you can look here, we should notice something. We should notice on the first two, we started with a less than or a less than or equal to, and both of those came out to be sandwiches or an and statement. The second two started out with greater than or equal to, and they came out with or statements. So this next page would be absolutely great to have in your notes. So here's what it says: to solve an inequality in the form of the absolute value of something is less than a value, where a is a variable expression, and b is greater than 0 because we talked about having 0 over there. We want to solve the compound inequality. Again, we got a sandwich. We got a sandwich here. So a negative b is less than a is less than a b. Okay. The second piece of it says to solve an inequality in the form of the absolute value of a is now greater than b, where a is a variable expression and b is greater than 0. We want to solve the compound inequality. A is less than a negative b, or a is greater than a positive b. Okay, so what does that look like when we're solving? Let's take a look at a few and you'll see. So again, if we start with a less than, that is an and or a sandwich. If we start with a greater than, that is an or statement. Okay, so let's take a look and see if we can do this. And sandwich, or excuse me, less than, sandwich, greater than, or. So if I take a look at a problem, for instance, number 18, we have a less than. So I know that it's going to be a sandwich type. So if I take a look at number 18, I know I'm going to write it like this. I know I'm going to have a negative 10 is less than an x plus a 3 is less than a positive 10. So once I have that written, I can solve that just the way I would have solved the compound inequalities before. I would get the x by itself by subtracting a 3 everywhere. So I would end up with a negative 13 is less than an x is less than a 7. What does that look like on a graph? Well, I'd have a negative 13, a positive 7. I know that I've got open circles at both, and I'm going to be connecting the two. Okay, on the next one, we have a absolute value of y plus 4 is greater than a 12, greater than. I know I'm going to have an or statement. So I'm going to have one of these. I'm going to have a y plus 4 is greater than 12, or y plus a 4 is less than a negative 12. And then we simply have to solve both of those inequalities. So on the first one, I'd simply minus a 4, and I'd have y is greater than an 8, or the second one, if I subtract a 4, I have y is less than a negative 16. So on a graph, I've got a negative 16, I got a positive 8, so that means I'm going to have an open circle at the negative 16, arrow to the left, open circle at the 8, arrow to the right. Next one, I've got absolute value of y minus 1 is less than or equal to 8. So what's that going to be? Less than or equal to, that is a sandwich. So I know I'm going to have a negative 8 is less than or equal to a y minus 1 is less than or equal to an 8. So how do I solve that? Well, hopefully we can see that I would add 1 everywhere. And I would get a negative 7 less than or equal to y is less than or equal to 9. And then I would go about graphing it. I'd have a negative 7 here. I'd have a positive 9 here. And I would have closed circles at both closed circle, and connect the two. Okay. And on the last one, we have a greater than. So if I have a greater than, I know it's going to be an OR statement. So I'm going to have the two inequalities. 3c minus 4 is greater than a 12, or 3c minus 4 is less than a negative 12. So I simply solve both of them. I would add a 4, and I get 3c is greater than 16, divide by a 3, and I got c is greater than 5 and a third. Or if I solve this one, I'd add a 4, and I'd get 3c is less than a negative 8, and I'd divide by a 3, and I'd get c is less than a negative 2 and 2/3. So what's that look like on a number line? Well, on a number line, I'd have a negative 2 and 2/3, and I'd have 5 and 1/3, and both of these would be open circles. This one would be going to the left, this one would be going to the right. Okay. So if I have to write an absolute value inequality for these, all real numbers that are less than 3 units away from 0, less than 3 units away from 0. So absolute value of less than 3 units away from 0. Okay. And the next one says at most 6 units from 0. At most 6 units away. So can it be more than that? No, it cannot. So at most, now I'm thinking, okay, these things have to be less than or equal to 6 away from 0. Okay. I'm going to let you try and, no, those are from yesterday, so you don't even have to worry about it. So this is where we end for the day. Okay, so that, my friends, is a wrap.